So question 15, we get into an application working with rational expressions. So let's look at this example here. So Lisa, she's an experienced shipping clerk, can fill a certain order in 3 hours. Tom, a new clerk, needs 5 hours to do the same job. Working together, how long will it take them to fill the order? So logic says if they're working together, it's probably going to be quicker than Lisa's time. So the answer should be under 3 hours. So the thing about this job is, how do we kind of create the ability to solve this problem? So one of the formulas we use is what's called distance. Distance is equal to rate times time. Well, the distance is actually the completion of the job here, or the completion of the order. So the completion of the order is going to be based on Lisa's ability to complete how fast she works and how fast Tom can work together. That's going to represent the completion of one order. So notice how there's only going to be one order in this problem. We're just trying to complete one order. So one thing to figure out is, how quick can how can we represent Lisa's ability and how do we represent Tom's ability? One of the things we pick up on is Lisa can complete the order in 3 hours. So when it comes to a rate, we need to know how fast she does something per hour. So if this represents the job or completing of the order, if it takes her 3 hours to complete the job, so this represents one job, one order. So basically, her in 1 hour, she's only going to be working a third. Only in 1 hour, she's only going to be doing a third of the job. So her rate is going to be this one third per hour, if you will. So if I look at Tom's he's going to use 5 hours to complete one job. Again, this rectangle represents the completing of the order. But notice how we want to know a work rate. So if it takes him 5 hours to complete the job, we know that if we cut this into 5 pieces, see if we can do this. We know then that in 1 hour, he will have completed a fifth of the job. The second hour, he would have completed 2/5, 3/5, 4/5, and then in 5 hours, he would complete the job. So his rate is going to be 1/5 per hour. He'll complete 1/5 of the job per hour. So if we put this all together, we don't know how long they're going to work together, but we do know their work rates. So Lisa is going to be working at a rate of 1/3 per hour, and we're going to be multiplying it by a certain time. That's going to be how much of the job she completes. And then we know that Tom is going to be working at a rate of 1/5 per hour. He's going to be working the same amount of time. And together, they're going to complete one order. So it's going to equal 1. So what I can do is write this as x over 3 plus x over 5 is going to equal 1. So that would be my equation for this. So this represents how much of the job that Lisa fills, and this represents how much of the job that Tom fills. But the question is how long does it take them to complete that one order? So what we can do to start with is we can get rid of fractions by multiplying by the least common denominator. So the least common denominator, notice how there's a 3 and a 5 there, so we need to multiply each side by 15. So since this is an equation, we want to multiply this side by 15, and we want to multiply this side by 15. So when we multiply by 15, notice how 15 and this 3 are actually going to divide out. 3 goes to 15 5 times, and we're going to be bringing a 5 through. That's going to give me this 5x. And then when I multiply this 15 to the x over 5, notice how this 5 is going to divide out the 15, and only a 3 is going to come through. So it's going to be plus then this 3x. And then 1 times 15 is going to be 15. So our equation becomes more what we call linear. 5x plus 3x is going to be 8x equals 15. And if we divide by 8, we have this 15/8 hours. So as far as hours go, it's going to be 15/8 hours is how long it's going to take them to do that. So if I put 15/8 into the calculator, 15 divided by 8, that would give me like 1.875. Now, if I want to change 0.875 into minutes, if I multiply 0.875 times 60 times 60, we would see it's like 52.3. So basically, it's going to take them 1 hour and about 52 minutes and 30 seconds if you really want to break that all the way down. I think we can just leave the answer in hours though. So 15/8 hours does not reduce, but notice how if I did change that out, that would be like 1 hour, 52 minutes, and zero point 0.5 minutes is 30 seconds. So 52 minutes and 30 seconds would be that conversion if I actually broke it down in hours, minutes, and seconds. So that answer sounds reasonable because they should be much quicker than together than they are separate. But notice how she's working at a faster rate, so she's probably completing more of the job than he is at his rate. But in the end, together, they're both kind of happy because they've done the job at a quicker rate altogether. So or a quicker time, I should say. So 15/8 hours would be the answer to that. So see if you can kind of walk through that one again. And these are kind of called working together problems. You can also go on YouTube and check these problems out because they're not the typical problem that we see in math, but it is a very, very real problem in the real world.